measures of spread, or sometimes you might hear it as measures of variation. Definitions. A range is the difference between the greatest and least values in the set. So it's your maximum minus your minimum. Your quartiles is values that divide data into 4 equal parts. And that should make sense because you have the word quart, which means 4. Your upper quartile, which is also known as Q3, is the median of the upper half of a set of numbers. So you take the upper half of the numbers and find the middle. Your lower quartile, which is known as Q1, is the median of the lower half of a set of numbers. So the lower numbers, find the median of that set. And your interquartile range is the range of the middle half of the data. So it's going to be your upper quartile, or Q3, minus your lower quartile. So it's going to be the range of the middle set of your data. And an outlier is a data item that is far from the rest of the data. And it is at least 1.5 times the IQR above or below Q1 and Q3. So VIC number 1 states that box plots, or box and whisker as you're used to, are commonly used to show the spread of data. So if you look at our box plot, our lower extreme is one of your whiskers on the lower half of the data, and it's your minimum. Then your maximum is your other whisker on the box. Your Q1 represents the first part of the box. Your median is the line inside the box. And your Q3 is the other half of the box. The box itself represents your interquartile range, so the range of the middle set of your data. Now, a box plot, remember, is a graph that is used to show groups of numerical data through the 5-number summary. And we're going to use the 5-number summary also to help us figure out outliers. So your 5-number summary is going to include your minimum, your Q1, your median, your Q3, and your maximum. As you can see, there are 5 of them, so that's why you get your 5-number summary. And VIC number 2 is that a box plot divides the data into 4 equal parts, even though visually it might not look like they are 4 equal parts. It's always divided into 4 equal sections. So let's look at an example using how to make a box plot and whatnot. So it says make a box plot given the data 16, 15, 20, 13, 14, 12, 10, and 12. So the first thing you need to do is find the median. Well, remember, anytime you're finding the median, you must put the numbers in numerical order. So I rearrange these numbers, mark them off from both sides, all the way, and if you notice, my median falls right in between 13 and 14. Well, since it's in between 2, remember you take the average of the 2 numbers it's in between. So 13 plus 14 divided by 2 gives us the median of 13 and a half. Once you find your median, now you're going to break the data into 2 equal halves. So this would be your lower half, and then this would be your upper half. So then you need to find the median of the lower and upper. This will find Q1 and Q3 for you. So the median, halfway in between the lower half, well, 12 is in between 2 12s. 12 plus 12 divided by 2 is 12. So our median, or our lower quartile, is going to be 12. Now you'll do the same thing for the upper half. It falls in between 15 and 16. And that median would be 15 and a half. So Q3 is going to be 15 and a half. So that's going to be our upper quartile. Once you found that, you also need to find your min and your max. So our smallest number was 10. That's going to represents our minimum. And our maximum was 20. Once you have found all 5 pieces of the 5-number summary, we can use those to make our box plot. That will be our last step. So once in all my 5-number summaries are underlined. So we would label that our minimum is at 10 and our maximum is at 20. So this would be your max. This would be your min. Now our median would be this line that falls at 13.5. So almost at 14, but not quite. Our Q1 was at 12. So this is the outside of the box. Our Q3 was at 15.5. Oh, I've got that a little too far. Let's try maybe right about here. 15.5. And so now we have 1, 2, 3, and this is Q3, 4, 5. So we have all 5 parts. Connect your minimum to the box and your maximum to the box, and you now have a box and whisker plot. To find our IQR, so to find the range of the middle set of the data, we can use this box plot to easily do that. It's going to be your Q3 minus our Q1. So 15.5 minus 12 is 3.5. So the range of our data for the middle set of the data would be 3.5 units. We can also use spread to determine if a set of data has an outlier. And VIC number 3 states that you can mathematically determine if a set has an outlier by using the interquartile range. So in the past, you have just looked at data, oh, that looks far away. Now we're going to mathematically determine if they actually are outliers. So it says, using the previous example, determine if there are any outliers. So we're going to use the same numbers that we used in the previous slide. Step 1 in finding this is you need to find your IQR, which is what we did in that box plot. So you have Q1 and Q3 from the previous slide, and you're going to subtract them. IQR is Q3, so 15.5, minus 12, which is your Q1. So our IQR is going to be 3.5, which we found in that previous slide. Now, step 2 is you're going to multiply the IQR by 1.5. You are always going to multiply by 1.5. And when you do that, it gives us 5.25. So this is going to help us figure out how far out our outlier can go before it's actually an outlier. Step 3, it says determine the lower extreme value, take the Q1 value, and subtract, this is important, from your answer in number 2. So what that means is you're going to take your Q1 and subtract it from the number that we just found when we multiplied our IQR. So 12 minus 5.25, and it gives us 16.75. We're going to do the same in step 4 to find the upper extreme, but we're going to add Q3 by the same number in step 2. So 15.5 plus 5.25 gives us 20.75. So this 6.75 and 20.75 tells us how far out from the main part of the data our numbers can go before they are outliers. So step 5 is to figure out if we have any outliers. So any outliers would have to be at 6.75 or less, meaning it has to be 6.75 or below to be an outlier. And or 20.75 and above, so 20.75 or greater. So if we look at our data, at 10, we don't have any number less than 6.75. And if you look at 20, we don't have any numbers greater than 20.75. So since we do not have those, then there are no outliers in our data set. So let's look at one more example and try to figure this out together. So the first thing, remember, we're going to do is find our median. So I need to cross these out. They're already in order, luckily. Makes it easy. Cross this out, and we found out that our median is 5. So now we need to find out our Q1 and our Q3. So we take the lower half of our data, so 2, 2, 3, and 4. And then we take the upper half of our data, 5, 6, 6, and 12. And to find the Q1, the lower quartile, we need to find the median of the lower section. So our median falls right here. So our Q1 is going to be 2.5. Now if we look over here, it falls right in between two 6s. So our Q3 is going to be 6. Once we have our Q1 and Q3, we can find our IQR. So this is us. Once we have the basic information, we can move into figuring out if we have outliers. So remember, IQR is Q3 minus Q1. So we have 6 minus 2.5. So we are going to get 3.5 as our IQR. Once you have your IQR, you're going to multiply that number by 1.5. So we have our IQR times 1.5. Remember, it's always 1.5. So 3.5 times 1.5, and we're going to get 5.25. Now, we can use this to figure out how low and how high we can go before we have outliers. So the first one, it's always your Q1 minus the number that you find, so 5.25. Well, our Q1 was a 2.5. So 2.5 minus 5.25, if you notice, we're going to get a negative number, and it's going to be a negative 2.75. Which means that if it's an outlier, it has to be at or below negative 2.75. Now we need to see if there's an upper extreme. So that's going to be Q3 plus 5.25. So our Q3 was 6 plus 5.25, and that is going to give us 11.25. So what these tell us is that we have to have either a number at or below negative 2.75. So if we look, our lowest number is 2. So we do not have a lower extreme value or a lower outlier. Now if we look at the upper part of our data, it had an outlier is at 11.25 or higher. Well, if we look, we have the number 12. The number 12 is larger than 11.25, which means we will have an outlier, and our outlier is the number 12.